In this video, you're gonna learn how to build your own marketing mix model from scratch, and I'm gonna walk you through every step of this process. So stick around to the end and let's get started. You don't need any programming experience or marketing experience. And this is gonna be all for free. You don't have to have any investments. The only thing you need is a little bit of time and data available. You're also gonna learn what data to use in the model and how to format that data in a Google spreadsheet. You're gonna learn how to run the model, how to read the data that the model provides, and how to improve the accuracy of the model. And ultimately, you're gonna get the most efficient budget allocation that provides the highest return on investment using machine learning. Hi, my name is Andrew Oss, and for the last 4 years, I spent close to $5 million on paid advertising, helping different businesses to grow. And one of the major components that was always present throughout my journey is proper budget allocation and attribution. And this problem has been always a big challenge, and I constantly try to find ways to allocate budget most efficiently to increase return on investment. So as you probably know, multi-touch attribution is very reliant on online signals, which were significantly impacted by iOS 14 update. First-party pixel tools like Triple Whale, Northbeam, Hyros, they're pretty good at click-through attribution, but if it comes to view-through attribution or cross-device attribution, they're really lacking a lot of signal. And as a result, channels like YouTube, Facebook, all the top funnel channels, it's pretty much impossible to attribute the view-through conversions from those channels. And businesses that don't have that top of the funnel view-through conversion attribution visibility are probably leaving a lot of money on the table, and it's hurting their business. I've tested so many different tools that help attributing. One of them is marketing mix modeling. So marketing mix modeling uses regression modeling, which aims to basically correlate different variables to revenue. What's good about marketing mix modeling is that it uses holistic approach to help you understand the bigger picture. It helps you understand the impact of online and offline marketing activities on your business, like seasonality, price changing, competitor sales, things like that. You can customize it however you want. You can add a bunch of variables, and it's really flexible. However, the big downside to that, and that's you're gonna learn if you're gonna try to do it yourself, is that it consumes a lot of time, especially data collection process takes a lot of time, and formatting data and just iteration of the data. But it's still pretty good. I think it's not a good standalone solution, and it's really important to know the objective that you're trying to achieve with the marketing mix modeling. And it's also good to have data from your tracking tools and post-purchase surveys, GeoLift, study data if you've done things like that. So first, we're gonna download and install R packages. And since I have Mac, I'm just gonna download the R package for Mac. And I also have Mac with M1 chip, so I'm gonna get this one. And now let's get the RStudio. Now let's just wait for it to download. Now let's just open and install our R package first. Once we got our R package installed, I just installed the RStudio, and it's really simple for Mac. And let's just open it up now. Your model's output is as good as the data you provide to the model. So the data collection part is crucial to the predictive ability of your model. And the data that you select to your model will depend on what you're actually trying to find out, what business questions you're trying to answer. So it could be things like how specific creative type is performing in a specific placement, or it could be how does a specific channel perform versus other channels. So usually the more granular you go, the better it is, but it also depends on a few other different factors. And one of the things that you can also try to find out is how things like GDP growth, unemployment, inflation, consumer confidence, weather, any other variables that you can think of, as long as you have the data for, you can add it to your model and see if there's correlation to your revenue. So a few more things that are really important in this step is that you need at least 2 years of weekly data. You can use daily data, you can use monthly data, but what I found is weekly data works best because the daily data could be really noisy, but you can try to experiment. So a rule of thumb would be for every independent variable, you need 7 to 10 rows of data. In this scenario, we have revenue as dependent variable, and all of these variables are independent. So for every row of data, for every independent variable, for this one, we would need at least seven rows of data. Yeah, since we have 9 independent variables, we're gonna need to have at least 63 rows of data. And you also need to make sure that there's sufficient volume of data and there's variation. And if your business has different business units or different products that target completely different audience, there's no overlap, it might make sense to create a separate model for each unit or for each product category. So in case you have daily data like I have right now here, you might want to know that it's gonna be pretty noisy for the model to pick up the correlation with daily data. And sometimes when you just change the daily to weekly, then all of a sudden the accuracy doubles. So what I'm gonna do here, I'm gonna group the data by week, and the way I'm gonna do it, I'm gonna use the pivot tables. So or pivots, so I added this extra column, and it's basically just the week num and taking the date column. So it's really important, by the way, to note that Robyn needs to have the date formatted in this specific way. So since we have 2 years of data, daily data here, we're gonna just try to group it by day, by year as well. Just have 2 different spreadsheets, and we're just gonna add them all together again. But I added this exact same row here that would just help me. So what we're gonna do, we're gonna select the first year of data, and we're gonna go to insert, pivot table, new sheet, create. We're just gonna name it as 2021. And then for rows, we're gonna add week num. That's how we're gonna group it by. And then for values, we're gonna just add all of the values except date. So revenue, Facebook top of the funnel, Facebook retargeting, YouTube retargeting, YouTube top of the funnel, Google search brand, Google shopping, and sale, and consumer confidence index. So consumer confidence index, we're not gonna, so as you may notice, it's basically grouping the data together by week. So but consumer confidence, we don't need to summarize it by, we're just gonna use the average. So that's good for this year. The way we're gonna do it, we're just gonna copy paste all of this data, add a new spreadsheet, and then we're gonna copy paste it here without any formulas. So we're gonna do Control Shift V or Command Shift V on Mac, and then we're gonna do the same thing for the next year basically. So now since I have the data in two different spreadsheets, we're gonna also add the year column. So 2021, and here is gonna be 2022, and this is and now we also want to double check the data, basically reconcile it to daily spreadsheet. So we also gonna just clean it up a little bit, so remove some of just all the extra namings. Okay, and then we're gonna also remove the average as well. Average of. Okay, let's just do it manually really quick. So here. Okay, some reason. Just quickly fix it here. So now we're just gonna remove all of these grand totals, and from here as well. And basically we're just gonna look at the column, the revenue column, look at the sum here down below. We can change it to sum, and look at the daily data, so and see if it matches. We can also use formulas to do good. Okay, yeah, this looks great. So now essentially what we're gonna do, we're gonna just add the date column again. So for date here, we're gonna use specific date formula, and you can just basically copy paste here. So let's do this, and then let's just get rid of this day. So here we have a situation where basically it just falls in the same day. So I'm just gonna basically Control C, Control V, and then shift this a bit up, and then add the new date here, and then I would format the numbers in a specific scenario that Robyn needs. So this is the correct year, month, day, and there we are. This looks all good, as long as we keep consistent. So every day is Monday basically, so that's good. And all right, and we actually, since we kind of copy pasted it without formula, so Control C, Control V, Control Shift V, we don't need these columns anymore, so we have a nicely formatted spreadsheet here. And we can essentially delete these, we don't need them anymore, and we can just change this to weekly. All right, so now we have nicely formatted data. All right, so one last step before actually running the model, we're gonna install all the packages. And the way we do it, there's actually a quick start guide, and this is written way that's gonna guide us. But we also need the demo script. We can just get it here. Just gonna copy, and then we're gonna basically paste it over to our RStudio. And the way you can do it, you can just do file, new file, our script as well. So we're just gonna paste it over here, and basically we can just follow the guide here. I have these packages installed, but there's some things that you're gonna need to install only once, and then you don't need to have them installed. But yeah, so let's just kind of go through it. So Let's see. So first we want to do is to install packages. Let's see. So basically, yeah, it's asking me if I want to restore the R. I'm just gonna select no. I'm just gonna run this code. So we have the packages, and then let's go install this one. Oh, yeah, and so by the way, the way you can also run the code is you can select it here, and you can just click the run button. So the pound sign kind of prevents the code from running. So if I would select this code and execute, it wouldn't execute. So if I wanted to execute the code, I would need to move the pound, but since it's just one-off installment, we're just gonna install it and proceed with this. So we got remotes installed, and let's just basically this is gonna get us the newest version, Robyn, basically. Oh yeah, so basically it's kind of the same as this, but this one is the latest version. So we're just gonna roll with this. Let's see. It says it's done. All right, and then let's just run this one. So it looks like we got the library. And then the next thing we're gonna do is let's also check the package version of Robyn. Okay, we see the package version. Then let's see. So this is basically gonna force the multi-core. So if you have different, most likely you have a lot of cores in your processor. So basically we're gonna use this as well. We're gonna run it every time basically, but and we can also specify how many cores the model is gonna be using, because later down the road, but this is enough. We're just gonna execute this code. So then we're gonna install the Nevergrad. That's the Python library. So let's see, there's just some suggestions, and let's see, we're just gonna select this and run it. You'd probably want to restart the R. I'm just gonna say no, but you probably need to select yes. So it's installed, and then we're gonna install the Nevergrad. Oh yeah, so now we installed the reticulate packages, and then we can also just do this. So we're gonna remove these pound signs, and let's see, so we're just gonna select all of this and hit run. So then once it's installed, we're just gonna add the pound sign, so it's not gonna be run the next time we execute the code. There's another version, but this one is working well. So it says if there's, in case it still can be installed, you can try this. But so far it's been working well. So that's it for the packages installation. And now let's add our data to the model and configure it. So now once we install all the packages, we're just gonna need to do one thing, which is enable the library reticulate, so we can load it every time we run the model. So I'm just gonna remove the pound sign. So then let's just walk through this thing. So let's just walk through every step of the process. So first step, we're just gonna load the data. And in this scenario, Robyn package provides the simulated data. I'm gonna do something different. In this case, we're gonna use our own data set. So you can also just test the model using this data set. But in this case, I don't need that. So I'm just gonna add the pound sign, so this one is not run. Then there's this spreadsheet with holidays that is already provided by Prophet. So we're gonna keep this because we want to know how the holidays and seasonality and all of that affects our revenue. And then the directory where we want to export results to. Let's just keep it as is. And then if you let's see. So here we're basically gonna specify. That's where kind of we set the parameters for the model. So DT input is the data set input, so that's basically the link to a spreadsheet. The way we're gonna do this is we're gonna just add the link to our file. And the way we're gonna do this, basically we're gonna just add data, table, file read, fread, and then we're just gonna add the link to the data set we have. And by the way, as you might have noticed, this is basically the list. So the input collect, and there's comma after each line here, and you might notice there's no comma here. We're just gonna add it here, and the way actually we're gonna see if this works. We can just do head dataset input, and then we can basically run this thing. Let's see, let's run this, and then let's run this without comma. You don't have to do it, but I'm just running this just to see if it's working. So it's working. And then we're gonna keep the holidays in, keep this as is. Notice the data format is must be this. Then okay, so this is the dependent variable, which is revenue, and then the revenue type, the variable type, which is revenue, which is just the name of the variable. Then profit variables, which is trend, seasonality, and holiday. We're just gonna use it, so no changes here. Then profit country, here is Germany. We're gonna change it to the US. Notice there's only 59 countries and holidays 59 countries, so gotta change it to your own country. And if the country is missing, you can change the spreadsheet, or you can create your own with the holidays, or even modify the existing model data set. Then we have context variables, which is competitor, sales, discounts, employment, etc. We gonna add, so in our model we have sales and consumer confidence. So we might even add those in here. So sale and consumer com. So that's the name of the columns we're gonna add, and that's the data we have in our spreadsheet. Over here, basically. So then we're gonna just delete all this here, and also so this is paid media spent. We're gonna add the spends for each channel we have in data set. This paid media variables, we're not gonna use this because it's basically the search, clicks, and impressions. It says it's mandatory, but really it's not necessary. And the most important thing is spend here in this case. So let's see, we don't have any organic variables, so we're just gonna and factor variables. If you want to run the model for a specific period of time, you can modify this. I'm just gonna add the pound here because we don't need that. We want to run the model for the entire period. And then add stock, so it could be geometric, it could be Webull or Weibull, CDF or PDF. We're gonna do the this one. So this one has basically better capabilities. It takes way more time to run, but it has beta capabilities of finding the ad stock changes for paid social channels and yeah, things like that. So all right, so we got we just need to add our pay media spans here, and we're just gonna copy them from here, but you can just copy them from here. We're just gonna do this, and then oops, it didn't work. Just give me a sec. Okay, now it should work. Just gonna add the quotation marks. All right, so I think this should be it for now. All right, so then we can move to the next step. And actually, let's first just verify if it's gonna work, if there's no issues. Profit signs must be a valid factor. But okay, let's just remove this. We don't need this, and then we're gonna basically run this code and see if it works. Just select it here and run it. So it looks like it worked well. So now once we have done this step, we're gonna move to the next one, which is hyperparameters. So we're just gonna execute this line here, and this what's gonna do is just gonna show us which hyperparameters we're gonna need for the ad stock. And here we're gonna change the plot ad stock to true, because we wanna plot the saturation points and the ad stock itself. And so let's see, so we're gonna get so basically you can read these, read all this, and there's interpretation for each ad stock option. What I've tested all of them, and I think this one is just the most advanced, and you can read up more on this one. And they provide just basically the boundaries for shapes and thetas and scale. But we're just gonna scroll down here, and so what you're gonna see the list of parameters already. So we're just gonna basically add the hyperparameters for Weibull ad stock. So I already have them ready here. And basically, if you want to add a new channel, if you have like new channel, so then you just copy paste this and just change the name of the. So let's say you want to add, you have a column called TV spend, right? So you just change TV, and then it's gonna be like this. But we don't have TV, so we just gonna delete these lines. So that's what we have for now. I'm not gonna go into detail. Again, you can just read up on this and optimize. For now, I'm just using the recommended parameters by Robyn, but it's something to optimize potentially in the future, because this basically will affect the ad stock component of the model. Train size, we're just gonna use the default size here, and then we're gonna roll with it. We're gonna just add 1 comma here as well, and we can just basically run this and see if there's any issues with that. Oops. And so so this basically adding hyperparameters into the Robyn inputs into the model list, and then there's also option to calibrate the model. I'm not going to explore this in this video, but the way you basically do it, if you have some geotaste data, if you have some ground truth, you can calibrate the model using this section basically. So let me know in the comments if you want me to record a video about the calibration model part here. But for now, we're just gonna roll with it. So this is basically also related to calibration. So let's just move to the next step. So spend exposure fit, let's just run this, and then we're just gonna skip this part because it's not needed right now. So this step is actually where we run the model. So we're gonna basically set the number of cores to 6 or actually 5, because that's the number of cores I'm willing to use. But if you can just leave null as the default, and then number of iterations and trials. So we're gonna go with 3000 iterations and 5 trials here, but this is just for example purposes, and it's gonna take faster to run the model. Usually you'd go as much as you can afford in terms of your PC capacity. And also depending on how much data you have. So if you have a lot of data, and if you have a good computer where you can, and you have time, so you can probably leave the model running overnight with maybe 7,000 iterations, 10,000 trials, or just 10 trials, sorry. So the more iterations and trials you have, the higher the chance of getting the most accurate model. But ultimately, the data is the most important thing. This is just enough for the amount of data we have. We're just gonna leave this at false. But if you want to run this, basically this gonna help you to see how the model prediction versus the actual data. And the penalty factor, we're gonna leave this at false as well. This is usually used if you have some channels that are penalized by the model because of maybe the model thinks that there's not enough data, but you really have strong opinion, or you have some other data that proves that that data actually is relevant. So maybe you want to play around with this variable. So all of the other variables here we're gonna leave as is. The only thing I changed is the parade of fronts. So we're gonna use 5. That's just basically number of one page model output we're gonna see. So, but yeah, everything here we're gonna leave as is. So the Rybyn object is the folder. So here I actually changed this to that's basically where our model files are gonna be saved. So let's just quickly Robyn object. So it's gonna be saved at desktop, but I actually want to save it. And by the way, if you want to organize your model in a more easier way to navigate, so each step you can just basically collapse. You can add a lot of pound signs. So basically, if I want to add a lot of pound signs here, I'll be able to collapse this this part of the code. So yeah, we have the inputs ready. So I'm just gonna run the model, and I'm just gonna select all these steps up until step. Let's see. Actually, we need only the steps. Just steps 3. So these are the steps we're gonna run, and then Then we're gonna see the overview of the data, and we're just gonna wait till it's finished. Now the model basically ran for about 25 minutes. We can see how much time each trial took to run, and basically we can see the entire overview of what the parameters that the model took into itself. So now the model is basically done. We can see all the parameters and then the data and how about the model, how much time it took to run. So now we just can go ahead and analyze the data. So let's see, this is the model we ran. So basically here in the Rybyn folder we have the one pagers, and we have some other files here. So here we can see the RAS convergence chart over a number of iterations for each channel, and basically we would be looking for peaky distribution chart. So the peak here, the chart is kind of the higher the confidence, but that's just like one of the data points. We just kind of want to look here, see how it kind of developed over the number of iterations. So now let's just open up these models and kind of look at them individually. So here we're gonna be looking at highest R2 train and lowest RSSD, as well as also an RMSE as well. And we also gotta use our knowledge of the ground truth of the things like we might have used some post-purchase surveys, some geo-lifts that we conducted, and maybe third-party tools that we know that some channels actually convert, and maybe we try to test them in some other ways. But essentially we just kind of want to find the model that makes the most sense according to what we know about the business, and also model that has the highest the best metrics here as well. It looks like this model has the kind of the highest R2 train and the lowest RSSD, and from what I can see so far, it kind of makes sense the way at least the decomposition waterfall, the response decomposition waterfall is laid out here in the chart. So let's just kind of select this model individually and just go through each chart. So the first chart here is basically just gonna show us how each marketing channel or event or things that we're modeling for kind of affecting our revenue. And so basically intercept here means that this would have happened, this amount of revenue, and would have happened if we didn't spend anything on the marketing side of things. Then we have different channels, and then we can see how sales and holidays affect our business. So basically this is the percentage of revenue driven over the period of time we're using the data, so attributed to each channel. So let's see, consumer confidence, for example, here is basically caused the 29% of revenue decline. If the consumer confidence didn't change basically since the beginning, we would have 29% more revenue. That's kind of how you can read it. And then so actual versus predicted response. So this is how the model is kind of fitting. The actual is yellow, the blue is predicting. So this is kind of the model is using the past data to kind of try to predict the past data as well. And this is how it was able to predict it. So then we have share of spend versus share of effect with total ROI, and we have here's basically ROI for each channel. And then effect share, this is the revenue percentage that the channel has generated. And then we have the spend share, which is percentage of total ad spend that was spent on each specific channel. Here we have in cluster bootstrap ROI with 95% confidence intervals and mean. So what it means is basically how confident are we that the mean ROAS is actually 2.1 for this specific channel, for example. So there's 95% confidence that the ROAS for this channel is between this specific interval. So here we're gonna be looking for like shortest intervals. So for example, there's really high chance that Facebook top of the funnel and retargeting and then search top of the funnel, they're in between these intervals, so between 2.3 and 3 for Facebook retargeting, for example. And for search brand, for example, there is really high interval, so it could be 0, it could be 4.3, the mean is 1.8. We don't know, basically, the model doesn't know. So that's how you kind of can interpret it. Then we have Weibo PDF ad stock. It shows how lagged the effect of advertising on specific channel is. So for example, here we have basically this is number of weeks, and we have the revenue kind of not being generated, and then so we spend money on advertising here, and then we kind of increases, and then we can see the results starting from the week 7, right? And then they kind of increase. So maybe we can draw some learnings from here as well. Where some other channels, they have like more immediate effects of advertising. And then also there's immediate versus carryover response percentage. So basically it shows how it just gives insight into how quickly consumers are purchasing after interacting or engaging with the specific channel. So for example, shopping here would be 39% of conversions kind of came immediately after, or I'd say conversion value immediately after interacting with the channel, where 61% were delayed. Here search like 100% were immediate. So that's kind of all that means. And then we have response curves and mean spans by channel. So that's kind of saturation curves. So Robyn tries to predict where's the saturation point, where's the inflection point of spend for a specific channel. So we kind of see the modeling, so how much we would spend and how much we would get for the specific channel. So let's say Facebook top of the funnel, we can see that we could spend 50k, we'd get like roughly 150k, 140k. But then if we kind of spend 100k, right, we'd get 250k. So there's point of diminishing return for each channel, and you can just gotta see how it makes sense for your business, or the business that you're modeling for ROAS wise. And so Robyn is not really good at predicting this, by the way. So you gotta be really careful when you're making decisions based on this graph, just because it uses the historical data and it doesn't have the insight into the future, and it's just kind of hard to predict like the saturation point usually, because you might unlock some sort of other audiences, sort of other messaging or new product that's gonna, give you that new potential of scalability. And then this chart basically shows the variance in terms of the historical data and predicted data, and then so what are the things basically the model can see and can predict, and those things basically, like the outliers would be like this one and this one here. So these two, for example, the model, they're really like far away from this line, and so what that could mean that there's some data points that are missing. Basically, one of them kind of distributed around this area, and if you have lots of them like kind of far away, and then this that means that you might add some more data points to the model. The gray area kind of means the error effect of the model, and then so that's kind of how it looks like for this specific one pager. And now we're gonna try to use the budget allocator of Rybyn to allocate the budget, basically. So let's just get started with that. So we're gonna go back to the model. We're going to use let's see, where's we're gonna find the code here. So we're gonna select the model. So what's the model name, and then we're gonna add it here to the model, basically select the model. So now let's go ahead and use Robyn budget allocator to allocate the budget based on the model we just created, and based on the data the model spit out to us. So basically there are two ways we can use budget allocator tool. Is first one is maximum historical response. Basically, what's the revenue lift potential with the same historical ad spend we can get, and what's the spend mix. And the other one is we can give the model spend, and then the number of days, and the Robyn will optimize the budget to get the maximum revenue or maximum response. So in this case, we're gonna use, I'm just gonna go through the entire part of this code. So basically we just can go ahead and do this print function. So it just basically gives all the parameters that exported model has. So the model we selected, and where we select the model, we select the model here, just to remind you. So and also we can run the Robyn allocator here to see the basically FAQ, see which of these function mean what. If we want to use this function, we're gonna need to select the constraints as well. So constraints, for example, here need to be the same. There needs to be the same number of constraints as we have marketing channels, basically ad spends. So we're just gonna go and find number of channels we have added to the model, and that's 1, 2, 3, 4, 5. And basically this is going to be the order we're going to set up the constraints for. So these 5 ad channels here. Now let's go ahead and add those constraints. So we're gonna do 50%. So basically what it means is 3, 4, okay, So each of these constraints is basically how much. So 0.5 means 50%. So they mean what will be the boundary of budget allocation that we can go lower. Like, what's the lowest boundary of the budget allocation that the Rybyn can go? And this is going to be the highest budget allocation. So if we have, for example, Facebook top of the funnel campaigns, and we have it at 0.5 at low constraints, so then the budget won't go, Robyn won't decrease the budget by more than 50%. And same with here. So for example, if we do 1.5, 1.5, 1.5, so it would be the highest boundary. So if it's 1.5, that means the Robyn won't increase the budget by more than 150% for a specific channel. And you can also read all of this here. So and the boundary, the lowest that can go is basically 0.01, and the upper bound should be less than 5, so no more than 500%. Then let's see what we have here. So basically, do you want to export it or not? So here with the date, it kind of means how much, what would be the time frame the Robyn would look for the mean ad spend to take into account. So let's say if you want to just look at the last 30 days of our model, then we just select 2023, 2022. Okay, 1201, and then 2022, something like that, for example. So the Robyn will just look at the last 30 days of the model, and then take the budget, the mean budget, and then redistribute it for each, basically by each channel. So this one, we're not gonna use this, but let's just kind of use this one and see where it takes us. All right, so we can go to our folder and see the budget reallocated basically. And let's kind of open the graph first and just kind of walk through each parameter here. So with the same, so we can also use the Google Sheet as well, but with the same budget we had in the last 30 days, if we just reallocate according to this specific model, we'd have 12.6% higher revenue coming from paid media if we reallocate the budget according to the model again. So here we can see the initial versus optimized budget allocation, and here we can see the initial versus optimized revenue from all of these channels. And here you might see that the search brand, the model recommends that we should really just decrease the budget, half the budget essentially, by 50%, and that's where we set the boundaries. So maybe if we set the boundaries to 0, Robyn would just decrease the budget, completely eliminate this channel. So basically Robyn suggests to increase the retargeting on Facebook, decrease the top of the funnel traffic here on Facebook as well as increase search, top of the funnel ad spend, and decrease the budget on shopping. So if you can see, basically if you sum up all these percentages, you should get 100%. So if you sum up all of the optimized average spend share, you should get 100% of the budget. Yeah, there might be some channels that don't show up here, and then maybe just Robyn decided to eliminate them completely. So but that's kind of the revenue, the response that we should theoretically get. And then we have the response curve here as well. So that's kind of how basically we can see the triangle is the optimized ad spend, and the initial that's basically the graph from the first one pager PDF that we had from Robyn, and we can see where the budgets are within a certain time frame where we selected again. So yeah, that's kind of how it is. There's a little bit more to that, but that's just the initial step with the model. Obviously suggest you to not blindly trust the model output and use other data points like you know, your first party data, maybe some other third-party tools like Triple Whale, Northbeam, Hyros, and then kind of use the basically click data from those tools, as well as post-purchase survey data, and then you can, you know, kind of get an idea of what to do. And then once you run the model for and once you basically get the budget allocation and you're confident in the budget allocation, then you can change the budget according to the model. Maybe it wouldn't make sense to change it like so drastically. Maybe it would. It obviously depends on the specific case. Maybe there's some fat to trim in the campaign, you know. And so if you do that and then you kind of wait, trying to not overspend or underspend, just kind of stick with the budget and see kind of how overall profitability or revenue, depending on the metric you're optimizing for, changes. You know, the marketing efficiency ratio. So if it's kind of in line, you just stick with that, and then 1, 2, 3 weeks you kind of reassess the effect of the reallocated budget. It's better to have more granular approach when it comes to marketing mix modeling, just because you can have more actionable insights, and you can actually see where you can reallocate the budget. So for example, maybe it's image versus creative type, or part of the funnel, or maybe some specific offer that you have. Maybe you're running different product categories and you do that. But that's kind of that's it for this specific video. Please type in the comments whatever questions you have, whatever requests you have. I'll be happy to record a video and find out the information for you.